Alright, everybody. Sorry I couldn't be in class today, but I was gonna say Vietnam. I'm in Taiwan right now with the cross country team. We're flying. We're having a great time. So operations with complex numbers. If this doesn't make sense, you can always look in your book for this too. So first thing we have to talk about is we have to find an imaginary number. What is an imaginary number? So here we go. If you start with this equation right here, and we solve it, so we subtract 9 from both sides, normally we would stop right here and we would say that there's no solution, or we'd say no real solution. But in this case, we can use our properties of radicals, so we can separate 9 and the square root of negative 1, and we can rewrite this square root of negative 1 as I. And that's my imaginary root, so that's my imaginary component. So that square root of negative 1 is defined as I, and I is my imaginary component. So yeah, that's where it comes from. I did not mean to do that. So that's the first thing. So our imaginary numbers comes from the square root of a negative number, and I can always separate that out. Alright? So next, here's some examples of stuff you can do. Instead of just leaving it as the square root of negative 3, I can separate it out as my real component and my imaginary component. So I can just rewrite that as the square root of 3 times I. Here's another example. If I have I times the square root of 7 squared, I have to distribute both of those pieces. I distribute that squared to both of these, so I end up with I squared and then the square root of 7 squared. Now, I squared is the same as the square root of negative 1 squared, which is just negative 1. So I end up with negative 1 times 7, which is 7, or negative 7. So easy. So throughout your examples, you're just going to be doing this a lot. You're going to be simplifying these radicals. Alright, complex numbers. Every number that we have can be written as a complex number. The standard form of a complex number is a plus bi. A is the real part, and bi is the imaginary part. So here's an example. 3, which is a real number, can be written as 3 plus 0i. It means the same thing. The square root of negative 4 can be written as 0 plus 2i. And remember, the square root of negative 4 can be written as the square root of negative 1 times the square root of 4. When I take the square root of 4, I get 2. When I take the square root of negative 1, I get my I value. Alright, so now let's add complex numbers. When we add complex numbers, I have 7 minus 3, that's my real part, which is 4. And I have negative 6 minus a negative 6i. I have negative 6i minus a negative 6i. So a negative and a negative are going to make this positive, make this negative. So I end up with 4 plus 0i, which can also be written as just plain 4. Both mean the same thing. This looks like the easiest example. 8 plus 5 is 13, and negative 1i plus 4i gives me 3i. So 75% of your homework over 4.6 is just going to look like that. Alright, now we're going to write it in standard form. So what happens if I have a multiplication? I need to distribute this to both pieces. So I distribute it there and here. I get negative 24i plus 4i squared. Now the cool part is this I squared can be simplified. If you remember before, I squared is equal to the square root of negative 1 squared. And if I square that, then I'm just going to get negative 1. So I have negative 24i plus negative 4. But I have to rearrange the order. Remember, it's a, which is my real part, plus bi. So I always have to put it in that order. I can't make an I. There it is. Then if I have two binomials, remember this was a monomial times a binomial. So two binomials I can distribute again. So I get negative 36. Bam. Bam. plus 63i plus 8i minus 14i squared. So once I have this, I'm not done. It looks like I have some common terms that I have to put together. And what does I squared equal again? You remember? Oh yeah, -1. Sweet. So I have my -1. 63 plus 8 gives me 71i. And because it's -14 minus 1, that turns into positive 14. So my solution, again written in the a plus bi form, is just -22 plus 71i. Easy. Oh, look, I have your notes right there for you. All right, so one of the last things we have to do is we have to rationalize the denominator. So just like radicals, we don't like imaginary numbers in the denominator. So in order to eliminate the I term, we multiply by the complex conjugate. What is the complex conjugate? Do you remember what conjugate is? So if I start with a plus bi, my conjugate is a minus bi. So we'll take a look at this. 7 plus 5i divided by 1 minus 4i. What is the complex conjugate of the denominator? So if it's 1 minus 4i, it's going to be, write it down, 1 plus 4i. Sweet. Those i's are tough to make. So if I multiply the bottom by 1 plus 4i, I also have to multiply the top. So now it's just algebra. It's just like the previous slide. We distribute so that we get the top, and we distribute on the bottom, and now we just need to simplify. Remember, what does I squared equal? I squared is always going to be -1. Same thing here, -1. So that's going to give me a positive 16 on the bottom. These cancel out, which is nice. So 1 plus 16 is 17, and on top, 28 plus 5 is 33, and 7 minus 20, because that's a -1, is -13. So my final answer, notice on the bottom, I have a real number, and on top, I have a complex number. Easy. All right, the final thing you guys have to learn is absolute value of a complex number. So this is what it's going to look like on your homework. 4 plus 3i, the absolute value of 4 plus 3i. What this means is I need to graph it. So instead of having a y-axis, this is my imaginary axis. And instead of having an x-axis, this is my real axis. So if I look at this number, a is 4. So I go over 4. 1, 2, 3. So this value here is 4. And then my non-real part, or my complex part, is 3. So I go up 3. 1, 2, 3. So this value out here is 3. And then when I'm looking for the absolute value, or what I'm looking for is just the hypotenuse of this right triangle, I just use Pythagoras. A squared plus b squared equals c squared. So that gives me the absolute value. So the square root of 4 plus 3i, the absolute value of 4 plus 3i, we graph it like this. Remember, this is my real axis. Let's see if I can spell real. This is my imaginary part. So I know I'm going to go over 4 and up 3. So here's 4. This is 3. And I want to find this distance right here. Because it's a right triangle, it's easy. Pythagoras is a squared plus b squared equals c squared, or I just take the square root. Oh, actually, it's written right here. So I take the square root of 4 squared plus 3 squared is square root of 25, which is 5. That's the answer. All right, guys, this is enough. You guys are just practicing 4.6, so it's on Canvas. You don't even need a book. So get rolling. Your assignment's right here. I will run fast for you guys this weekend. Thanks.